Hey guys, welcome back to my channel. So today we are going to see the analysis of a beam column joint under a cyclic load testing. Okay, so this is the model that have been modeled and imported to the ANSYS mechanical part. So if you ask me the geometrical specifications of this model, so I would like to show you some specifications here. So this is the same model which I have imported in the workbench. So this is a concrete body. Uh, and there is a loading panel here. So you can see a loading panel which is 50 mm wide and 20 mm of thickness. So then it is a reinforced beam column joint. So in case if you want to see the reinforcement, so you can see the reinforcement here, uh, which is may having here. So what all things, the 12 mm diameter is provided for the column side, and 10 mm diameter is for the main beams, and all these stirrups and ties are of 8 mm diameter. So these are the geometrical specifications of this model. The same model has been shared to the ANSYS Mechanical, so which I will be concentrating here. So you can see this model here. So this is a T beam column joint. So what materials is the material concrete material is being given to the co- entire concrete body. So the loading panel is taken as structural steel. So all other the entire reinforcement. So here, let me show you the reinforcement. So the entire reinforcement here is of structural steel. That and one more important thing is you have to make this as a reinforcement. Okay, you should make sure that it is a reinforcement. So then it will act as a reinforcement. Then the answers will consider it as a reinforcement. Okay. So now coming to the mesh properties. So I have taken a very fine mesh at the location where I'm going to apply the load. So at the free end of the beam. So we can see that I have applied a edge sizing. So to get a proper uh, meshing at the interface of the edges of all the pedal with the beam, I have applied the edge sizing. So here there are two things. So one is a horizontal and one is of the width. So two different sizes you have to apply there. Otherwise, it will become too fine for this. So here number of divisions 5. So whereas for this corner, the number of divisions I have given as 10. Okay. So since it is a deformable body, so we can keep the behavior as soft. So in case if I was using it was on the steel or reinforcement or rebar, so then I would have kept it as a hard part. Okay. So fine. So this is how it is being done. So you can see for the rebar cage inside. Let me show the rebar cage. So here for the rebar cage as well, I have applied the edge sizing. Only thing is I have made the total number of divisions as 20, and because of which the behavior is really hard. So this is what has been created till now. And this is about the meshing part. And if I have to speak about the reinforcing part, so refinement. So what I have made is taken a refinement of the loading area. So where I want the mesh size to be very fine and which will give me better results. Fine. So this is all about the meshing. So I have considered the element size as 15 mm and considering the span angle center as medium. By default, it is coarse. So but I will consider that as a medium now. And then I will run this analysis. So before that, so we have to apply a load. We have to do certain apply the boundary conditions. So I have applied fixed boundary conditions at the two faces of the column, and due to which uh, it will not deform. This part is not allowed to deform. So the only load applied will be at the free end of the beam. So next one is the remote displacement. How I am applying the load in the form of a displacement. So just explain what settings you have to make to apply this as load. So what you have to do is in the analysis settings, you have to create the number of steps uh, as 40. So whatever is required for your analysis, you can create that. So here I have turned on the auto time stepping is turned on, and the initial substeps are 10, minimum substeps are 5, and maximum substeps are 60. So this will ensure a proper analysis. So here the number of steps 60, like the load will be applied in this pattern, what you are seeing here. And please keep the large deflection on so as to simulate the nonlinear behavior of the beam column joint. Okay, so this is the settings that you have to make sure for the nonlinear analysis of the beam column joint under cyclic loading. So then let me explain about the remote displacement, how you can apply. So when you create the number of steps as 40, so automatically there will be 40 rows that have been generated here as a tabular data. So since I am loading in the x direction, so you can see the load is applied along the x direction. I have to consider the x component to be tabular. So for the x component, refer the table for the cyclic load. Okay, it means like referring to the table to apply the load. So the software refers to this table, whatever you input here. According to that, the graph is being shown here and it will apply. And the rest all other components I have kept it as 0, y, z, and the rotations at all the points x, y, z is 0. And you can turn off these things here. So it's not necessary. So only time and x displacement is being written. So I have created from starting from 14 mm to around 42 mm with the interval of 4 mm. With a step of 4 mm, I have applied the load. For example, it is 0. Initially it is 0. Then it will go to 14 plus 14 minus 14 plus 14 minus 14, and again it will come back to 0. You can see here 0 mm, 14 mm, minus 14, 0 mm, minus 14 mm, 0. Again, just by an increment of plus 4 mm, similarly you have to repeat 18, minus 18, plus 18, minus 18, 0. Again with an increment of 4 mm, 22, minus 22, 22, and minus 22. So in this way, you have to apply the load till 42 mm. Okay, so this is what I have been applied for this beam column joint. Okay, so after doing so, then you have, while doing the solution, please make sure that you select this beam section results as yes, and then and run the analysis. So it will take considerable amount of time. So for me, it has taken, you can see here, 33 minutes. 33 minutes 45 seconds it has taken, so which is, I think it is too long. So hence you have to keep it for uh, some time to the analysis, and then later on you can analyze the result. So then I got the, after the analysis I got the deformation part here. So you can see the results which I have got. I will only consider the maximum values. So just to run the simulation, you can see how the load is being applied at this end. So the total deformation 45, that's a maximum part. So if you want the x direction, only in x direction the deformation. So this is what is being the x form 43.621 mm. Deformation of the beam. This is the deformation of the beam. Okay, so where it is showing the red color. So This is the free end deformation maximum value. So similarly, you can refer some other results. So maximum principal stress. So if you want that result, you can even get that. Uh, so this is around 8.429 mm. So you can still see that this beam has not reached its failure load, or it is still capable of taking the load. So in that case, we can increase the displacement value. Uh, so further increase the displacement, remote displacement load here, so that it will reach the maximum principal stress, which is specified around 30 megapascal for this beam or the concrete. Till then, you can start loading. Uh, so now, if I start loading, it will take time. So, but this is how you can start loading. And one more thing, what I can just show you is you can create a named selection and specifically concrete. So you can rename this as concrete. So specifically uh, uh, to see the part-wise stresses. If you want to see the part-wise stresses in the beam, in the concrete or in the steel, so select the named selection, and it will be observed here. So you have to again retrieve this result. So once it runs, so you can see that it is almost same. That it is 8.429. It is in megapascals. So still, the beam has a capacity to withstand the load. So we can continue this process until it fails. And in this way, you can analyze a beam column joint under a cyclic loading condition. Hope you guys have liked video and found it more informational. So we'll meet you in the next video. Till then, thank you. And if you have any doubts, please drop those in my comments. Okay, thank you.